Okay, solving inequality using multiplication or division. This learning target is very similar to target 2, where we're still working with one-step equations, but this time we're talking about multiplication and division. The reason I split inequalities the way I did is because addition and subtraction is very similar to solving equations. But multiplication and division, while there are some similarities, there's also one really important rule about multiplying and dividing that a lot of people forget. And it's something very simple. Someone will do an entire problem correct, but their answer will still be wrong because of one minor mistake, usually at the very end of your inequality. So what we're going to do is we're going to start looking at multiplication, and we're going to get into what that rule is and how we need to solve our inequalities using that rule. So first thing I want to start with is the multiplication property of inequality. We had addition property and subtraction property of inequality, so we're moving on to multiplication, and we do have a key concept box similar to the ones we've already looked at. And what I want us to focus on first is this statement right here. We have A, B, and C, and they're real numbers, but C is specified here, unlike some of the others we looked at. C has to be greater than 0. So ask yourself, what type of numbers am I talking about if C has to be greater than 0? Well, hopefully you're coming up with several different examples, and all those examples revolve around positive numbers. So C has to be positive. We're not talking about any negative numbers here in this first concept. So let's look at what happens when C is positive. Our first example is if A is greater than B, so A is a larger number than B. If I multiply both sides by that positive C, and I'm going to highlight the C here in blue, if I multiply both sides of my inequalities by a positive C, notice that AC is greater than BC. My inequality symbol has not changed. I have created equivalent inequalities, and my symbol still remains a greater than sign. The same thing holds true when you have a less than sign. If A is less than B, then if I multiply both sides by that positive C, the product of AC is still less than the product of BC. So again, equivalent inequalities, and my inequality symbol itself has not changed. So fairly simple, but this is where we're going to get into where you could make mistakes, and we're going to try to eliminate that right now. Try to help you remember this. This concept is when C is less than 0. So you may already know what we're talking about here, but think about all the examples of numbers that are less than 0, and all of them revolve around being negative. So C has to be a negative number, -4, -3, -0.5, any negative number you can think of. So let's see what happens when we use a negative number for C rather than positive. So let's look at this first one. If A is greater than B, so similar to what we had up here, A is a larger number than B. If I multiply both sides by C, and now this time C is negative, don't forget. If I multiply both sides by this negative number, look what happens to my inequality symbol. It flips or reverses, whatever is the best way for you to remember that. It was a greater than symbol, now it's a less than symbol. I have equivalent inequalities. Just like we talked about in the first video, we have equivalent inequalities. The only difference is because I am multiplying both sides by a negative number, it's going to flip or reverse that inequality symbol. Again, the same thing holds true whenever you have A less than B. If A is a smaller number than B, no matter what that number is, these numbers can be positive or negative. They are not specified. They are all real numbers. So it doesn't matter what these numbers are. If A is less than B, when you multiply both sides by that negative value, your product, AC, is now going to be greater than the product of BC. So anytime you multiply by a negative, this is the rule right here that's very important to remember. If you multiply both sides of your inequality by a negative number, your inequality symbol itself is going to flip. It changes the meaning of your inequality. That's why you have to reverse your inequality symbol. So let's just look at, give you a minute to look at this diagram. Remember, this also holds true for greater than or equal to and less than or equal to. So if you just look at this diagram, some of you all that are a little more visual may appreciate this diagram some, but it gives you examples of -2 is less than 3. This is a true statement. And what we've done with -2 and 3 is we've multiplied both sides by a +2. And notice that -2 times 2 is -4. That puts us way back here. And 2 times 3 is 6. That puts us way up here. So that's why our inequality symbol did not change when we multiplied by that +2. It pushed the numbers even further apart. Now let's look at this one. We have 3 greater than 1. 3 is greater than 1, which is a true statement. But what we've done to this problem is we've multiplied both sides by a -2. Well, notice what happens. If I take 3 and multiply it by -2, that pushes me all the way back to -6. And if I take 1 and multiply it by -2, that pushes me back to -2. But look what happened. The product of 1 and -2 is now going to be larger than the product of 3 and -2. It pushed it even further backwards. So it reversed the order of our inequality symbol. So that's what happens whenever you multiply by a negative number. Now it's easy to remember when we set it up like this, but what you have to make sure you do is when we start solving inequalities, if you are multiplying by a negative number to isolate your variable, then you have to remember to reverse your inequality symbol. So let's take the multiplication property of inequality and let's apply that here to problem number 1, multiplying by a positive number. Alright, so we have this inequality, x over 3 less than -2, and we're also going to graph these solutions. Now, x over 3, a lot of you all recognize this as the fraction x over 3, but what's the other meaning to your fraction bar? It's a fraction, it's a grouping symbol oftentimes whenever we're solving equations, and it's also a division sign. So multiple things there that fraction bar will mean. So we're going to use it as a fraction or as a division sign. So I'm going to rewrite this inequality. And let's think about this. If we are dividing by 3, the inverse operation of dividing is multiplication. So we're going to multiply both sides by 3. Now, notice that this is a 1 in front of this x. So this is like 1 over 3. So when you're multiplying, you're actually multiplying by the reciprocal of this fraction. Now, not the x. We're just talking about the numerical value. If this is 1 over 3, the reciprocal of that would be 3 over 1. And the reason why I'm going over that, and once you do to one side of your inequality, don't forget, just like equations, we have to do it to the other side. But the reason why I'm going over that is because I want to make sure that you understand that I'm not multiplying 3 by 3. I'm multiplying 3 by this fraction 1 over 3. Remember, there's an understood, I'm going to make it like a little dotted line, there's an understood 1 in front of that x. So the inverse of dividing by 3 and multiplying by 3, this is why we can mark these out. That becomes 1, which leaves us with our 1x, and that's your goal there, to isolate your variable. And then on this side, -2 times 3 over 1, or just -2 times 3, because we don't have to have that fraction, is -6. Now ask yourself this, we're multiplying by a positive number, and what was the rule? Did the inequality symbol change in our concept box? And it does not. When you multiply by a positive number, your inequality symbol does not change. Now I do understand this is negative, but notice that's not, I didn't multiply by -2 on both sides. I multiplied by a positive 3 on both sides. So since that was the positive number, this is my inequality. And now we need to graph the solutions to this inequality. So set up your number line. -6 is our starting point. Be very careful setting up your number line here. This would be -5, this would be -4, -7, -8. And you should be fairly confident with yourself in being able to graph these now. This is a less than sign. We are not including negative 6. There's not an equal to under here. So less than negative 6. So I'm going to have an open dot. I have to start there, but I cannot include the negative 6. And I want x to be smaller than negative 6. So every value I can think of needs to be smaller than negative 6. So that would be to the left. So there's your graph. All right, so multiplying by a positive number. I would like for you to take a minute and do this your turn question. Pause the video, copy this down, and solve this inequality for C, and make sure that you graph the solutions. All right, so we have multiplied by a positive number, so now let's look at multiplying by a negative number. Now, with this problem, a little bit different than the last one, we're going to multiply by this negative 3/4, or we're multiplying currently by this negative 3/4. This is a greater than or equal to sign. So let's go through the process here of multiplying by a negative number. So negative 3/4 W greater than or equal to 3. I'm just rewriting the inequality so I can see it better here. Negative 3/4 is multiplying by W. This is a multiplication problem. They're side by side. The inverse of this, a lot of times of multiplication, is division. Okay, but we're going to actually set this up a little bit differently, and you can do this when you're solving these on your own any way you like, but we talked about this in problem number 1, that when you multiply, you're actually multiplying by the reciprocal of your fraction. We had 1/3 in the last problem, and we flipped that to 3/1. So if I am multiplying here by 3/4, or a negative 3/4 in this case, to move this, I can multiply by, so I'm going to have to multiply this entire side by the reciprocal of this fraction. Now it's still negative, but I flip the 3 and the 4, and it becomes 4/3. Now if I multiply this side by a negative 4/3, just like with equations, I have to make sure that I multiply the other side by a negative 4/3. So I've multiplied both sides by a negative number. So that should clue us in that this is that special case with multiplication. Now because I am multiplying 4/3 and negative 3/4, these are reciprocals of each other, and a negative times a negative gives me a positive. I can mark these out. This is where my 1 comes from, so I'm left with my 1W. And always type that in your calculator if you're not sure. Negative 4/3 times negative 3/4 will give you 1. So W, and then we're going to multiply these, 3 times negative 4/3 is going to give us negative 4. Always type that in if you're not really sure. Multiply those. Now we have to think, multiplying by a negative number. I multiplied both sides by negative 4/3. And I'll actually highlight that just to emphasize that we multiplied this side by negative 4/3. We multiplied this side by negative 4/3. We multiplied both sides by a negative number. And so that should clue us into that rule that now my inequality symbol is not a greater than or equal to sign. I have to reverse this, and that gives me a less than or equal to. So there are all of my solutions to that inequality. Now it does tell us to graph and check this time our solutions. So to graph this, set up our number line. Negative 4. This would be negative 3. This one would be negative 2, negative 5, and negative 6. All right, so less than or equal to, that clues me in, equal to. I am going to be able to use my negative 4, and I'm going to kind of do my check all at the same time. If I plug negative 4 in for W, is negative 4 less than or equal to negative 4? And that is true because they are equal to each other. So that is a closed dot. I have to start there, and I include that number. Now I need to figure out, am I going to the left or am I going to the right? Well, this could be part of your check. Let's plug in negative 2. Is negative 2 less than or equal to negative 4? True or false? And that is false. Negative 2 is not less than negative 4. Alright, so if negative 2 doesn't work, we can assume, and we could try these numbers also, that negative 3, negative 1, 0, those do not work. So let's go in the other direction. Let's try negative 6. So negative 6, is that less than or equal to negative 4? Negative 6 less than or equal to negative 4, and that is true. We can try other numbers through here, but since negative 6 works, this tells us that all of the numbers here to the left are going to work. Alright, so multiplying by a negative number. So take that and apply it to this your turn problem. And this is very similar to actually problem 1 in the way it's designed, but be careful, that is a negative there. And solve this inequality, graph it, and then be sure to check your solutions after you've graphed it. Alright, so we've discussed all the multiplication, so now let's talk about division. Division property of inequality. We have another key concept box here. We're going to take this step by step for division property. I'm going to cover up our diagram here, our examples. And let's just start with the first one. And this is very, very similar to, let's look at this first, very similar to multiplication. C greater than 0. Just like when we had multiplication, if C is larger than 0, think about all the numbers that are bigger than 0, and they all revolve around being positive. So we're talking about only positive numbers. So, let's look at this first example. If A is greater than B, A is a larger number than B, if I divide, highlight this, if I divide both sides by a positive C, 4 is greater than 2, 4 divided by 2, 2 divided by 2. Well, that would still be a greater than sign. So if I have an inequality with greater than sign, I divide both sides by a positive C, I'm still going to have a greater than sign. Equivalent inequalities. The same thing holds true for less than. If A is less than B, if I divide both sides by a positive C, the quotient A over C is going to be less than the quotient of B over C. So your inequality symbol does not change. Now, here's where we get into what's similar to our multiplication. When C is less than 0. So again, just like with multiplication, we're talking about negatives. All of our negative numbers. C is less than 0. Alright, so if C is less than 0, let's look and see what happens when C is negative. A is greater than B. So just like this one up here, A is larger. But this time we're going to divide A by a negative C, and we're going to divide B by a negative C. So C represents a negative number this time. If I divide both sides by a negative number, look what happens to my inequality symbol. Just like with multiplication, if you are dividing by a negative number on both sides, it reverses your inequality symbol. It changes the meaning, so therefore you have to flip your inequality symbol. Same thing holds true for the less than. If A is less than B, then A divided by a negative C and B divided by a negative C is going to reverse your inequality symbol. It was a less than sign, it becomes a greater than sign. And all of these hold true for the inequalities with greater than or equal to and less than or equal to. So let's look at some examples. This one doesn't actually have a diagram or a visual, but it just gives you some examples. 6 is greater than 3. If I divide both sides by 3, I'm going to get 2 and 1. 2 is still greater than 1. Same thing holds true if it's a less than sign. 9 less than 12. If I divide both sides by a positive 3, 9 divided by 3 is 3. 12 divided by 3 is 4. 3 is less than 4. So dividing by, same thing with multiplication, by a positive number does not change your inequality symbol. It's when you get into problems like this, if you divide by a negative 3, and I'm going to write this one out just so you can actually see it. 6 is greater than 3, so if you divide both sides by a negative 3, what is 6 divided by negative 3? It's negative 2. And then 3 divided by negative 3 is negative 1. And so now notice, instead of having a greater than sign, I can't put a greater than sign there. Negative 2 is not greater than negative 1. So I have to reverse the symbol, and that becomes, that's where the less than sign comes in. So the same thing would hold true with your less than sign. You would have to flip that and make it a greater than sign. So division is just like multiplication. You've got to remember when dividing both sides by a negative number, it's going to reverse your inequality symbol. So let's take that and let's look at problem 3. And this actually is a word problem, so this will get us some practice in writing inequalities. We're going to divide by a positive number here because it tells us that. So when we set this problem up, this one's going to be a fairly easy one. Let's go through this word problem. Let's highlight the important information. All right, you walk dogs in your neighborhood after school. You earn $4.50 per dog. $4.50 per dog. So not bad. So you want to know, how many dogs do you need to walk so that you can earn at least $75? You don't want to earn exactly 75. It doesn't say to earn $75. You want to earn at least $75. So before we ever start writing anything, let's think about what that means. At least 75. Think about it in your mind. You're the one walking the dogs, and I tell you want to earn at least $75. Would you be happy with yourself if you earned $70? Probably not, because you want to earn at least 75. That's the least amount that you want to earn. What you hope to earn is more than that. So you'd be really satisfied with something like 80, 85, 90. You've gone over your baseline, basically. So this is going to help you to determine which inequality symbol you need to use. So let's think about what $4.50 per dog means. $4.50 per dog means if you walk one dog, you only make $4.50. If you walk two dogs, how much would you make? Well, you would make $9. And that's $4.50 times 2. So the 2, the 1, those two examples are representing the number of dogs that you're walking. Well, that's the question. How many dogs do you need to walk? So let's identify and define our variable. I'm going to let D represent, I'm going to abbreviate kind of here, number of dogs. D represents the number of dogs that you need to walk. Okay, so let's set up just what I have highlighted in yellow here, $4.50 per dog. Okay, so $4.50 per dog. Well, dog is D, so $4.50 times D, 450D. Now, you want to earn at least, and we just talked about this. We know it's going to be 75. We have to figure out our inequality symbol. Are you going to be happy with walking all these dogs and making less than 75? Would you be happy with that? No. So we know it's not going to be less than or equal to, because we don't want to make less than 75. We want to make at least 75, but we hope to make what? More than 75. So we know it's going to be a greater than sign because we hope that what we do over here is going to be more than 75. But could it be exactly 75? If this is your baseline, at least 75, then if you made 75, you would be okay with that. Just, you don't want to go any lower than that, just 75. So there's your inequality symbol. This is how you need to talk it through to yourself to try to determine what does at least or at most or whatever you have here, what does it mean? So talk yourself through it. All right, so here's our inequality. Well, we know we're going to divide by a positive number, so we know what to do. You're not always going to have this, but this kind of helps guide you right now. How is the $4.50 attached to the D? Well, they're side by side, so that indicates multiplication. So the inverse of multiplying by $4.50 would be to divide by $4.50. Now, if I divide this side by 450, I have to go to the other side of the inequality symbol and divide by 450. So you've got 450 divided by 450, which you want that because when you divide 450 by 450, you're going to get 1D. That's the point of dividing by itself so that you get 1. And then we have to multiply 75 by $4.50. And when you divide that, you are going to get a decimal. And it is a repeating decimal. So let's actually write it as a fraction, 16 and 2/3. Should be 16.6 repeating is what you get, but we don't write those repeating decimals, write them as fractions. Now, what do we do with our inequality symbol? We multiply both sides by $4.50. That is a positive number, so our inequality symbol does not change. It remains greater than or equal to. So this is our inequality. So D has to be greater than or equal to 16 and 2/3. Now, let's think about this logically though. Have you ever walked 2/3 of a dog? Now I know some of you make jokes, well, it could be missing some legs or that kind of thing. True, you could maybe make an argument. But there's no such thing as a 2/3 of a dog. So 16, well let's say, well maybe we just want to walk 16 dogs. Well, if we walk just 16 dogs, let's put it in here. Is 16 greater than or equal to 16 and 2/3? No, it's not. 16 does not satisfy this inequality. It is not greater than 16 and 2/3. It's actually less than that. So I can't say that walking 16 dogs is going to help me reach my goal. So analyzing this inequality, don't leave it like this. You've got to think back to what the question's asking you. D represents the number of dogs. So what is the smallest amount greater than 16 and 2/3 that you can walk in order to reach your goal of at least $75? Well, you would have to walk at least how many dogs? 17 dogs. So even though we have the inequality, that's well and good, but we need to make sure that we can answer our word problem there. 17 is greater than 16 and 2/3. 17 is the largest number that's greater than or equal to 16 and 2/3, or largest whole number, I guess I should say, because you can't have part of a dog. So 17 dogs, that's the least amount that you can walk in order to earn at least $75. All right, so that word problem, apply that to your turn problem 3 here. Very similar. And make sure that once you get your inequality that you sum that up and write a valid sentence explaining your answer. All right, so we've multiplied and divided by positives and negatives, or we've multiplied by positives and negatives. We've divided by positives. So the last thing that we have left here is dividing by a negative number. So we don't actually have a word problem here. We just have another simple inequality. Negative 9y, I'm going to rewrite this, negative 9y less than or equal to 63. Very simple inequality. We're also going to graph the solutions. All right, so how is the negative 9 attached to the y? Well, it's attached by multiplication, side by side. The inverse of multiplying by negative 9 is not addition, which a lot of people try to do because of the negative sign. Look at how it's attached. I could put a dot there. It's attached by multiplication. So the inverse operation is to divide by negative 9. So if I divide this side by negative 9, go to the other side of your inequality and divide that side by negative 9. All right, so what's a negative divided by a negative? That's going to give you a positive. And 9 divided by 9 gives me 1. So positive 1y, that was the goal there. Let's look at the other side. 63 divided by negative 9. Well, what is 63 divided by negative 9? That gives you negative 7. But let's think about what do we have to do with our inequality symbol. And I'm going to highlight this. We divided this side by negative 9, and we divided this side by negative 9. We divided both sides by a negative number. So clue us in that this inequality symbol is no longer less than or equal to. It has to reverse or flip and become greater than or equal to. So this is our answer. But let's graph it. And while we graph this, I'm actually going to check it and show you why we have to flip the inequality. So let's fill in -7 is our starting point. This would be 6, -6, this would be -5, this is -8 and -9. Greater than or equal to. So equal to, if I try to use my starting point, does my starting point work? Is -7 greater than or equal to -7? And that's true because they are equal to. So I start here and I use that number. And then we need to determine, based on our inequality for our solution, we want y to be greater than or equal to -7. We want y to be larger than. We know it's equal to now, so now we need to go larger than. Would that be heading towards the -9? Or would that be heading towards the -5? Well, let's try going to the right. Let's try -5. Is -5 greater than or equal to -7? And yes, that is true. So we are going to go in this direction. Now, what you have to be careful of is that if you failed to flip your inequality symbol, notice you would have had the correct variable, the correct number, the correct starting point. But if you failed to flip your fraction, or excuse me, your inequality symbol here, you would have had a less than sign. You would have gone to the left. Now to you, you would think that's correct. If you plug in numbers, -5 is not less than -7, -9 is less than -7. So your check, you would still feel like you are correct. Everything would work out for you here. However, if you were to take these numbers and plug them back into the original problem, and that's what I'm going to do, I'm going to show you that, the original problem. Let's try this -5. We said -5 works down here. Let's see if it still works up here. -9 times -5 less than or equal to 63. Well, what is negative times a negative? Gives us a positive. What's 9 times 5? 9 times 5 is 45, less than or equal to 63. Is that a true statement? And yes, it is. 45 is definitely less than 63. So notice the -5 worked down here and the -5 worked up here. So not only are my answers correct because of my solutions that I have here, but it's also correct because it works in the original problem, and that's what you hope for. If you did not flip your inequality symbol and you graphed everything this direction, you would have graphed -9. So let's see, does -9 work in this problem? -9 times -9 less than or equal to 63. Negative times a negative gives us a positive. 9 times 9 gives us 81, less than or equal to 63. True or false? And that is false. 81 is not less than 63. So notice that sometimes it's not enough to just check your solutions here to make sure that they work in your answer. But it's also good to try to check it in your original inequality to make sure it works, especially in cases where you're dividing or multiplying by a negative number, to make sure that you have flipped your inequality and you've graphed all the correct solutions. All right, so dividing by a negative number, here's your turn, problem 4. Solve this for x. So find your solutions to this inequality and then make sure you graph your solutions, and it would be good practice to check and make sure that your answers work in your solution and in your original inequality. All right, so that sums it up for multiplying and dividing by negatives and positives. So here's your summary question, and this summary question is actually matching. You have questions 1 through 4, and you've got A, B, C, and D. And what you have here is, well, we have your inequalities over here, so you're going to have to solve each one of these and determine what the solutions are and match those solutions to the correct graphs. So just list 1, 2, 3, 4 and write A, B, C, D beside those. Which inequalities match which one of these graphs?